when installing supplemental power meters and integrating them into a building automation system via a network, there are several National Electrical Code, or NEC, considerations that must be taken into account. These considerations are especially important if the physical size of the meters prohibits their installation within the main electrical panel, leading to a proposal to install them in junction boxes, or J-boxes, by running service cables through the meters. One key NEC requirement is 240.11, which mandates the grounding of service equipment. The meter enclosure must be properly bonded to the grounded service panel using an equipment grounding conductor. This ensures that any fault currents can safely return to the source, minimizing the risk of electrical shock or fire. Another crucial aspect is accessibility. NEC Section 373.8 stipulates that service entries must be readily accessible for examination and testing. Installing the meter inside a J-box may not meet this requirement, as the meter might not be easily accessible for routine inspections, maintenance, or troubleshooting. Similarly, NEC Section 408.33 requires switchgear to be accessible from the front or rear for maintenance and repair. If the meter is buried within a J-box, it would not be easily accessible for these purposes, potentially hindering necessary repairs or maintenance activities. Compliance with manufacturer's instructions is also paramount. NEC Section 408.36 requires that switchgear be installed in accordance with the manufacturer's instructions. The proposed installation method of routing service cables through the meter within a J-box might not be approved by the meter manufacturer. This could void the warranty or create unforeseen operational issues. Protection from damage is another critical concern. NEC Section 110.26F requires that wiring systems not be located where they are subject to damage or adverse conditions. Installing the meter inside a J-box could make it vulnerable to physical damage from impact or accidental contact, especially in industrial or commercial settings. In addition to NEC considerations, there are several additional factors to consider. Firstly, heat dissipation. Power meters, like other electrical devices, generate heat during operation. If the meter is enclosed within a J-box, this heat could accumulate, potentially overloading the wiring or causing the meter to malfunction. Proper ventilation or heat sinking may be necessary. Secondly, space constraints. The J-boxes may be too small to accommodate the meters, the associated wiring, and any necessary support devices. Overcrowding can lead to overheating, insulation damage, or difficulty in making proper connections. Thirdly, environmental conditions. J-boxes may not be weatherproof or rated for outdoor use. If the installation is in an environment exposed to moisture, rain, or other elements, it could lead to moisture accumulation, corrosion, and eventual failure of the meter or wiring. Finally, electrical clearance. The J-boxes may not provide sufficient electrical clearance between the live parts of the service cables and the metal enclosure. Insufficient clearance can increase the risk of electrical arcing, short circuits, or even electric shock. Given these potential issues, it's recommended to consider alternative installation methods. Instead of installing the meters within J-boxes, consider using a separate enclosure or meter cabinet specifically designed for this purpose. Such enclosures should meet the requirements of NEC Section 373.8 and 408.33, ensuring accessibility, grounding, and protection of the meters and service cables. These enclosures should be properly sized to accommodate the meter, wiring, and any necessary support devices, while also providing adequate ventilation and electrical clearance. In addition, the enclosure should be rated for the specific environmental conditions of the installation location. In summary, when installing supplemental power meters, it's crucial to carefully consider the NEC requirements and potential environmental and operational factors. Using appropriate enclosures and following manufacturer's instructions can help ensure a safe, reliable, and code-compliant installation. To elaborate further on NEC 240.11, the requirement for grounding service equipment is a fundamental safety measure. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly trip and de-energize the circuit. This minimizes the risk of electrical shock to personnel and reduces the likelihood of fire. The equipment grounding conductor, or EG, must be properly sized according to NEC Table 250.122, based on the size of the overcurrent protection device protecting the circuit. It must also be securely connected to both the meter enclosure and the grounded service panel. Moving on to NEC 373.8a, the accessibility requirement ensures that electrical equipment can be readily inspected, tested, and maintained. This is essential for identifying potential problems before they lead to equipment failure or safety hazards. Readily accessible is defined in Article 100 of the NEC as being capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. If the meter is buried inside a J-box, it may be difficult to reach without having to disassemble the J-box or move other equipment, which would not meet the readily accessible requirement. NEC 408.33 focuses on the accessibility of switchgear, which includes equipment like panel boards, switchboards, and control centers. These are critical components of the electrical distribution system, and they require regular maintenance and repair to ensure their proper operation. The NEC requires that switch should be accessible from the front or rear, depending on the specific design and configuration. This allows qualified personnel to safely perform maintenance tasks such as tightening connections, inspecting components, and replacing damaged parts. Placing the meter inside a J-box could obstruct access to the switchgear, making these tasks more difficult or even impossible. Compliance with manufacturer's instructions, as required by NEC 408.36, is essential for ensuring that electrical equipment is installed and operated in accordance with its design specifications. The manufacturer's instructions provide detailed information on proper installation procedures, wiring diagrams, and safety precautions. Deviating from these instructions can lead to equipment malfunction, reduced performance, or even safety hazards. It's important to consult the meter manufacturer's instructions to determine whether the proposed installation method of routing service cables through the meter within a J-box is permitted, and to ensure that all other installation requirements are met. NEC 110.26F addresses the protection of wiring systems from damage and adverse conditions. Wiring systems must be installed in a manner that protects them from physical damage, such as impact, abrasion, or crushing. They must also be protected from adverse environmental conditions such as moisture, extreme temperatures, or corrosive substances. Installing the meter inside a J-box may not provide adequate protection from these hazards, especially if the J-box is located in an area where it is exposed to physical abuse or harsh environmental conditions. In addition to these NEC considerations, it's important to address the potential heat dissipation issues associated with installing power meters in enclosed spaces. Power meters generate heat as a byproduct of their operation. The amount of heat generated depends on the meter's design, its operating voltage and current, and the ambient temperature. If the meter is installed in a small, enclosed J-box, this heat can accumulate, causing the temperature inside the J-box to rise. Elevated temperatures can reduce the lifespan of the meter, cause it to malfunction, or even create a fire hazard. To mitigate these risks, it's important to ensure that the J-box provides adequate ventilation to dissipate heat. This can be achieved by using J-boxes with ventilation openings or by installing a small fan inside the J-box to circulate air. Alternatively, consider using a larger enclosure that provides more space for heat dissipation. Space constraints are another important consideration when installing power meters. The J-box must be large enough to accommodate the meter, the associated wiring, and any necessary support devices such as terminal blocks, fuses, or surge protectors. Overcrowding the J-box can make it difficult to make proper connections, increase the risk of short circuits, and impede ventilation. It's important to carefully plan the layout of the J-box and to select a J-box that is large enough to accommodate all of the necessary components. Environmental conditions can also significantly impact the performance and lifespan of power meters. If the J-box is located in an area that is exposed to moisture, rain, or other elements, it's important to use a weatherproof or rated enclosure to protect the meter from these hazards. Weatherproof enclosures are designed to prevent moisture from entering the enclosure, while rated enclosures are designed to withstand specific environmental conditions such as extreme temperatures, corrosive substances, or explosive atmospheres. Finally, electrical clearance is a critical safety consideration when installing power meters. The NEC requires that there be sufficient electrical clearance between the live parts of the service cables and the metal enclosure of the J-box. This clearance is intended to prevent electrical arcing, short circuits, and electric shock. The required clearance depends on the voltage of the service cables and the type of enclosure being used. It's important to consult the NEC and other applicable standards to determine the appropriate electrical clearance for the specific installation. In summary, installing supplemental power meters requires careful consideration of several NEC requirements, including grounding, accessibility, compliance with manufacturer's instructions, and protection from damage. It's also important to address potential heat dissipation issues, space constraints, environmental conditions, and electrical clearance requirements. By following these guidelines, you can ensure a safe, reliable, and code-compliant installation. To expand upon the recommended solution, consider installing the meters in a separate enclosure or meter cabinet that meets the requirements of NEC 373.8 and 408.33. This would ensure accessibility, grounding, and protection of the meters and service cables. This approach offers several advantages. Firstly, it provides a dedicated space for the meters, allowing for easier access and maintenance. The enclosure can be designed to provide ample room for the meter, wiring, and any necessary support devices. Secondly, it allows for better environmental protection. The enclosure can be rated for the specific environmental conditions of the installation location, providing protection from moisture, dust, and other contaminants. Thirdly, it simplifies grounding. The enclosure can be easily bonded to the grounded service panel, ensuring that the meter and all associated wiring are properly grounded. Fourthly, it enhances safety. The enclosure can be designed to provide adequate electrical clearance between the live parts of the service cables and the metal enclosure, reducing the risk of electrical shock. When selecting an enclosure or meter cabinet, it's important to consider the following factors. Firstly, size. The enclosure must be large enough to accommodate the meter, wiring, and any necessary support devices. Secondly, material. The enclosure should be made of a durable material that is resistant to corrosion and other environmental factors. Thirdly, rating. The enclosure should be rated for the specific environmental conditions of the installation location. Fourthly, accessibility. The enclosure should be designed to provide easy access to the meter and wiring for maintenance and inspection. Fifthly, grounding. The enclosure should have provisions for grounding the meter and all associated wiring. Sixthly, safety. The enclosure should be designed to provide adequate electrical clearance and to protect against electrical shock. In addition to these factors, it's also important to consider the cost of the enclosure and its ease of installation. There are many different types of enclosures and meter cabinets available, ranging from simple metal boxes to more sophisticated designs with features such as viewing windows, locking mechanisms, and integrated cooling systems. Choose the enclosure that best meets the specific requirements of your installation. When installing the enclosure, it's important to follow the manufacturer's instructions and to adhere to all applicable NEC requirements. Ensure that the enclosure is properly mounted and secured, that all wiring connections are made correctly, and that the enclosure is properly grounded. After the installation is complete, it's important to inspect the enclosure and all associated wiring to ensure that everything is in good working order. Check for any signs of damage, loose connections, or other problems. Perform regular maintenance on the enclosure and meter to ensure that they continue to operate safely and reliably. In conclusion, installing supplemental power meters requires careful planning and attention to detail. By considering the NEC requirements, potential environmental factors, and the specific needs of your installation, you can ensure a safe, reliable, and code-compliant installation. Remember to consult with a qualified electrician or electrical engineer if you have any questions or concerns. They can provide valuable guidance and assistance in selecting the appropriate equipment and ensuring that the installation is performed correctly. The considerations discussed are essential for any installation of supplemental power meters, regardless of the specific application or location. Whether you are installing meters in a commercial building, an industrial facility, or a residential dwelling, the same principles apply. By following these guidelines, you can protect your property, your employees, and yourself from the hazards of electricity. Also, remember to maintain accurate records of all electrical work performed on your property. This includes records of the installation of power meters as well as any subsequent maintenance or repairs. These records can be valuable for troubleshooting problems, ensuring compliance with regulations, and demonstrating due diligence in the event of an accident. Consider implementing a preventive maintenance program for your electrical system. This program should include regular inspections of all electrical equipment, including power meters, to identify potential problems before they lead to equipment failure or safety hazards. A preventive maintenance program can help to extend the lifespan of your electrical equipment, reduce downtime, and improve safety. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always follow safe work practices and consult with a qualified electrician or electrical engineer if you have any questions or concerns. By taking these precautions, you can protect yourself, your property, and your community from the hazards of electricity. Always double-check your work.